this video, we're finally going to start putting together the model of the atom. But again, like, everybody's told you that there are protons, neutrons, electrons, and when you're younger, you don't question authority, right? But were you ever in your mind thinking, like, why do we think there's a proton? And what's this electron thing? Like, why do we think there are these negative electrons? And that's what we're going to try to answer in these next videos. And it all goes back to early experiments. So these are very famous experiments. J.J. Thomson is an English physicist who's famous for his cathode ray tube experiment. Okay, so he had this tube, glass tube filled with gas, and he hooked it up to an electricity source. Normally, when you turn on the electricity, it formed almost kind of like a laser beam, and the gas would glow in a straight line going across the tube. So we kind of expected something that might look more like this. Here's my little laser beam. This light going straight across the tube. Fabulous. We'll do something kind of similar in class. I do have tubes of light. We can hook them up to an electricity source, and it'll look like a laser. It's just going to have a beam of light glowing in a straight line. Alright, so now Thomson says, well, let's get a little funky here. And he took these charged plates. And so he's got one that's positive and one that's negative. Previous models of the atom, there really weren't any. I mean, before J.J. Thomson, they just had this Greek model, and the Greeks just thought atoms themselves were the smallest particles possible. So we could say, like the Greeks, just kind of thought, here's an atom. Here you go. Atom. Just these tiny little small blobs, I guess. They make up matter. It's awesome. They did not know that there are smaller components to an atom. Until now. Okay, so atoms are these tiny particles, and they also knew that they were neutral. And so they thought, okay, well, if atoms are just these tiny little neutral particles, they should not be affected by a charged field. So if I put a positive field against this laser beam with these glowing atoms, it shouldn't affect the beam of light. Atoms are just these little neutral particles. Or if I put a negative field outside of this little laser beam, I'm not expecting any change, because atoms themselves are just tiny little particles. They're neutral. They should not be affected by a charged field. And that is not what happened. Of course it's not, right? Otherwise that's not a very good story. The beam was no longer a straight line. When he put the positively charged plate on the outside of the cathode ray tube, the beam of particles bent. It was attracted to the positive plate. So we can make this like a little more aggressive. Which means that it was repelled from the negative. It kind of bent so that it was attracted to the positive, repelled from the negative. Wow, this was not what they expected. So now opposites attract and likes repel. So if my little laser beam, my charged atoms, my electrocuted atoms, they're attracted to the positive, repelled from the negative, there must be something in an atom that also has a negative charge. Thomson discovered that there must be a negative. Negatively charged particle in an atom. We're going to call this the electron. So J.J. Thomson is credited with the discovery of the electron with his famous cathode ray tube experiment. We put charged plates, positive and negative plates, on the outside of this tube that originally had a glowing laser that was a straight line. These atoms were glowing in a straight line. But not the case when they were subjected to a charged field. Okay, so now we're not going to argue with the fact that atoms are overall neutral. That was a known fact. That could also be tested at this time. The overall atom was neutral, electronically neutral, which then led Thomson to start thinking, okay, I've got some evidence here that there's probably some negative component to the atom, and this also makes some sense now. We know that the electron is on the outside of the atom, so it kind of makes sense if the electrons are on the outside of the atom that they might be attracted to a positive charge or repelled from a negative. We know now that there's a positive nucleus, which makes it neutral. At this point in time, Thomson's just going to say, there must be something else positive in the atom. There must be some kind of a particle with a positive charge. I don't know what it is, but it's there, because otherwise the atom would not be neutral. There's some kind of a positive component to the atom. The model that Thomson proposed is called the Plum pudding model. One year a student made plum pudding. I didn't ask him to. I didn't offer extra credit or anything, so don't get all excited about that. But they were like, oh yeah, we have plum pudding at Christmas every year or something. It wasn't very good. It's kind of one of those things where everybody ate it and had this big smile. And then when they're like, oh, would you like any more? Do you want seconds? Oh, no, I'm stuffed. It's weird. It's almost like a mushy bread pudding with chunks of fruit in it. It was awkward. Sometimes I like to think of this more as a chocolate chip cookie. I'm kind of a chocolate freak. I have to have chocolate every day in order to function properly. I don't need a lot of chocolate. I just need a tiny bit. I like to think of the plum pudding model as more of a chocolate chip cookie, where we know there are these chocolate chips. He's going to call them electrons. There are these negatively charged particles. He didn't really know what to do with them, or he didn't really know where they go. So he's just going to say they're like randomly scattered throughout the atom. So these little guys are the negatively charged electrons. So it's kind of like the chocolate chips. The positive component, he didn't really know. He just said there's got to be something positive so that overall the atom is neutral. So he said maybe it's just like these negative electrons are floating around in some kind of a positive material. Kind of like the cookie part. So this like background material, he's like, I don't really know what it is, but I don't know, maybe it's positive. So there's some kind of like a positively charged material. This background component, whatever it is, it's positive. So that overall the atom is electronically neutral. So at the time, I guess plum pudding was kind of a delicacy. So it's kind of like the plum chunks of the electrons floating around in a positively charged pudding. Okay, it's better than the Greek model because we do know that there are positive and negative components to an atom. Obviously, this isn't quite up to the times, but it's better. So J.J. Thomson, plum pudding model, credited with the discovery of the electron.